morning, students. Hope you are enjoying your online classes. Today, I am going to explain you, or I am going to introduce you with your first lesson, that is motion. You are very well aware of motion, and it is a very fascinating aspect of our life. You see birds flying, airplanes flying, rockets flying, mosquitoes humming. Everywhere there is a motion. Wherever there is life, there is a motion. But is that motion very simple? Is that motion the way we perceive, the way we see the motion moves? That's what we will discuss in our half an hour class. First of all, I would like to tell you few basic things. In this class, we will define motion, we will define rest, we will talk about distance, and we will talk about displacement. That's all. So, start with motion. When we talk of motion, the very definition of motion says that when a body changes its position with respect to a fixed position or a fixed point, the body is said to be in motion. That is the clear-cut definition. Repeat. When a body continuously changes its position with respect to a fixed body or a fixed point, the body is said to be in motion. Now the point is, what is the very basic content put in that motion, definition of motion? Two things. Number one, the fixed point. Number two, the continuous change. Well, we will discuss it later on. First, you might have heard about controlled and uncontrolled motion. You know, if I move this paperweight and I move it on that table, you don't know where it will go. If I just put it there, it can go anywhere. It can damage so many things. But if I move this paperweight, or instead of that paperweight, I move this gadi, and I am making it move, I can control it. I know where it will go, how far it will go, how much it will do. All those things I can find out. Well, now back to our very technical points. That is, number one, the fixed point, and number two, continuous change in position. Now, what can we say? What is my position? Am I in rest? Am I in motion? You don't know. First of all, you should know what is the fixed position. Now, I am standing here. It is around 6 feet away from this wall, around 4 feet away from the top wall, around 2.5 feet away from this wall. It means my position is 6 feet away from my right hand wall, here 2.5 feet away from this wall, and 4 feet away from the top wall. That is my position. Similarly, any object is located by its position in three axes that we call three dimensions. Now, suppose I am moving this elephant. My elephant is moving on this table and it is going. Now, the leg is also moving, the head is also moving, so this much part is moving, so its length is moving, its height is moving, complicated. I don't want it. I don't want it to move. This motion will be in 2 dimensions. Suppose I make it this move, it will move in length, breadth, height, all that. I don't want it. I want motion to be made more simple. So what I will do, I will take, instead of these 3 dimensions, I will take 1 dimension. And that is for you. For you people in 9th standard, we will be talking about motion in 1 dimension only. So whether I move this elephant, or I move this paperweight, or I move this gadi, all we will consider them as point body. Nothing more than point body, so that when they will move on a straight line along this table. So a motion in a straight line is rectilinear motion. Motion in a straight line, and that is our business. Fixed point I talked about in your study terms. In technical terms, what we call that fixed point origin. Remember your x-axis, y-axis thing. In your Cartesian, this is in your Cartesian coordinate where x-axis and y-axis meet, that point we call it origin. When you go to higher class, 11th class, you will come across one more axis that we call it z-axis. That altogether makes 3 dimensions. So for our considerations, we will take origin of our coordinate system as a reference point. Clear? Origin of our Cartesian coordinate system as a reference point. Now, we have decided our reference point. So my reference point is here, this Buddha. This is my reference point. Now, if I am changing my position with respect to this Buddha continuously, I am said to be in motion. I was there near Buddha, now I am here. And what I have done? Continuously changing my position with respect to this fixed point. So I am in motion. So when a body continuously changes its position with respect to fixed point, the body is in motion. So this Buddha is my fixed point, and this paperweight is continuously changing its position with respect to this Buddha. So the paperweight is in motion. Now, is it now changing its position? No. Now it is not changing. So now the same paperweight which was changing its position is not changing its position. So what we will call this paperweight? State of this paperweight will be state of rest. So we can define 2 terms. With motion, we got one more term, that is what we call rest. I think you will be able to define these 2 terms, motion and rest. Now the problem comes, what is the paradox? Now, you are sitting in a car and daddy driving the car. Are you in motion? Yeah, big question. Big question mark. Is car in motion? Big question mark. Is daddy in motion? Big question mark. Why? Because if daddy is driving a car and you are sitting next to it and you are in motion, what will happen? Daddy will give you a tight one. Just sit straight, don't move. But from your home to anywhere you can go in a car. So you have changed your position from your home to other place. You are continuously changing, your car is moving. Now the question comes, how can we make this motion more clear with these two concepts only? Fixed point and continuous changing. Then comes one thing. If somebody asks you, what is motion? Simply say, sorry sir, it is stupid question. Because what is motion is a stupid question. Why? Because in our experience, in our daily life, we come to know that motion is a relative term. You are sitting in a car, daddy driving the car is moving, but you are not moving. You are not moving with respect to car. Daddy is not moving with respect to car. But your car is moving with respect to the fixed point, your home to the road and all that. That's why when you sit in a moving car, you see trees and all those running away. So relatively, motion is basically a relative concept. So whenever somebody asks you what is motion or are you in motion, you say, sir, please say with respect to what? Here comes the importance of that fixed point. If you specify the fixed point or the origin, then only you can specify what a motion is. Your earth is moving, is it? Well, you know, earth is moving with respect to sun. So earth is in motion with respect to sun. You are standing at your place. Well, you are moving. Do you know how fast you are moving? You are moving around 27,000 kilometers per second. But you don't feel it because you are not moving with respect to earth. Rather, your earth is moving with respect to sun with just a big speed. So, what we learn? That motion is a relative concept, and whenever we talk of motion, we have to talk motion with respect to. Whenever we will talk motion, we will talk with respect to that fixed point. And what do you call that fixed point? The origin. And what we will talk about? Moving in a straight line. We will talk about only rectilinear motion. Motion in a straight line. Now the problem is, how can I find out bus is moving or not? So when you are sitting in bus and you see around or see outside the window the trees are running away, it means your bus is moving. But you are not moving in the bus. With respect to bus, you are not moving. So two examples I gave. Example is, the point is that whenever we talk about motion, we will talk about motion is a relative concept. Am I in motion? Yes, of course, because my position with respect to my little Buddha is changing. And it is changing continuously. So I am in motion. Motion can be very simple, can be very complicated. Different types of motion. See moving fan, see moving wheels, see moving, my moving to and fro, moving from there, going to there, again moving of pendulum. This is all motion. So different categories of motion, that is none of our business. Now back to our topic, to motion in a straight line. Now the point is, from my fixed position, Buddha, I continuously moved and came to this point. Now these 2 points, what is the length of these 2 points will determine another term in physics, we call it distance. So this, how much I have moved Well, say you may call it 2.5 feet. Further 3 feet. That much I have moved from my fixed position Buddha. When a body moves, what it does? It creates or it covers distance. Am I clear? Distance. So I am here in my Buddha and I want to reach there at this top. There. That round one thing. So what I do? I continuously change my position and reach here. How much I have moved? The distance. How do you measure this distance? We measure this distance in its SI units. We call it meter. So I have changed my position from this Buddha to this circle and covered, say, 1 meter distance. Distance is very interesting thing when we talk about motion. Two friends start from the school, home, in order to reach home, in order to reach school, what they do? They start from the same place and then they are reaching school. Somebody takes straightway here, home to school, that's all, full stop. Other one starts from home, goes to friend's house, say hello, hi to friend, and then again goes to the school. Did both of them cover the same distance? No. One student who started from this place reached straightway to school, of course covered less distance than one who started from there, went to friend's house, then again came back to school. He covered long distance. Now the point is, how can you differentiate? Science, we have to be very specific. Can we call both distance? Yes, one way we can call. But if I start from here and reach directly here, I got shortest distance. But if I start from here, go there, and then again come back there, it is of course not the shortest distance. So how can you differentiate between shortest distance and the distance? So they gave another name. That another name of shortest distance, in scientific term, we call it displacement. So displacement is the shortest distance between two objects. Now you got one more term, distance and displacement. Are they same? Of course not. They are different. Now the point is, what more difference you can find? Distance can be in any direction. I start from here, roam around, then go back. But displacement is in straight direction. Straight I go and reach here. So displacement is in a specific direction. Distance can be in any direction. Now, the point is, in physics, sometimes this direction troubles people a lot. So what they said, they will make a specific name for direction things. They said, okay, we will call it vectors. That vectors you will study in 11th standard in detail. But the point is, for our understanding, anything which has a direction is a vector, and anything which has no direction is scalar. Okay? So distance we call it scalar, displacement we call it vector. Another thing. If I start from here, go back to this point, again come back to my Buddha, What is my displacement? Nothing, no change in position. I started from Buddha, I am here at Buddha. So displacement is 0. But don't you think I covered distance? 1 meter I went here and 1 meter I came back. So 2 meter distance I covered, but my displacement is 0. Distance is 2 meter, displacement is 0. So displacement can be 0. With a moving body, displacement can be 0. But distance cannot be 0. When you are moving, you have to cover certain length of the path, and that length of the path determines your distance. Okay, now you know distance and displacement and motion and rest. One more thing comes. When we talk about motion, there is one more small silly thing. We call it uniform motion and non-uniform motion. If a body continuously changes its position with respect to a fixed body in equal amount, then the body is having uniform motion. For example, this is my reference point. My elephant is moving 10 centimeter in every second. So my elephant is moving with uniform motion. But now my this paperweight, it moved 10 centimeters in 2 seconds, another 10 centimeters in 10 seconds, another 10 centimeter in 1 second, another 10 centimeter in 10 seconds. No, it is not moving equal distance at equal interval of time. So, who is having uniform motion? My elephant or my paperweight? Of course, yes, my elephant. Why? Because my elephant covered equal distance in equal interval of time, whereas my paperweight did not cover equal distance in equal interval of time. So, you got one more term: uniform motion and non-uniform motion. Uniform motion is very theoretical concept, very rare. But in our day-to-day life, you can see non-uniform motion.